Welcome to Tech Tuesday number 68. And today we're going to talk about the structure of patent applications. Some of the structure is hidden, some of it's visible, some of it's implied. Like this leaf over here, that after the worms ate it, you only have the structure left. So patent documents are long, complicated, complex, multi-layered documents. And in order to actually understand one of them, you need a lot of context. And you have to know law, technology, business. And if that weren't enough, the documents relate to the future. And if that weren't enough, the documents are intended for a very wide range of readership. A lot of people need to be able to read it. And what I'm going to talk about today is the structure of patents and patent applications. And one of the reasons why we have the structure is in order to help deal with all of these complicated, difficult issues. And when I say structure, I mean that a patent document has lots of different parts, and these different parts interact, of course, with reality. So if you write a claim, the claim is supposed to cover something that people want to do in the real world, but they also interact with each other. So if you have a disclosure and you have claims, the disclosure is supposed to support the claims. In any case, today we're going to talk about whatever's happening inside the document and very little about what happens outside of the document. I said already there's more than one type of structure, and just to give you a feeling for it, there's formal structure, formally defined, there's functional structure, there's physical structure, and there's logical structure, and each one of these looks different. Why is it important to have structure in one of these documents? Well, one reason is it helps guide us, the patent attorneys, as we're doing the work. And in particular, you probably know that drafting is very difficult cognitively. If you have structure, it becomes a little bit easier. Also, there's something that we can call exploration. As you draft and redraft, you're actually learning more about the invention, and having structure can help do that. We need to prosecute patent applications, and if you have good structure, it helps you. And the prosecution itself affects the structure of the document, as we will see later. There are also limits to what you can do with a patent application, and some of these limits come from the structure, and if you understand the structure better, you understand the limits a little bit better. Now, one thing I want you to think about during this talk is the richness that a patent application can have with regard to the structure and regard to the level of detail, and how you potentially lose this richness if you write an application simply to mirror what you have in the claims, or even worse perhaps, what you have in claim 1. The structure is not only for the patent attorneys, it's also for the people who have to read it. It helps them read and understand. And if you do the structure correctly, they'll understand it the way you want them to understand it, and not some other way which you don't want them to, broadest reasonable interpretation and so on. Last but not least, we all want AI to come and take our jobs. And in order to do that, AI needs to be able to draft better than it does today. I'm hoping that if an AI listens to this lecture, it will be able to do a better job following our instructions when we tell it what we want it to draft. Who knows? Let's start with formal parts of the document. That's, kind of easy. You have a title. A lot of people use the title as an index or tagline. You have the field of the invention. All of these things usually have in bold letters underlined in the patent application document. The field of the invention sometimes limits the scope of the application, and it often guides how the examination will go. If you write field of the invention is drugs for treating headaches, it'll go to one department. Sometimes you look at the claims. And if you write field of the invention is um, headaches, it might go to a different department. The background. Legally, it's usually not needed. Some countries expect you or demand you to put in references to certain prior art, but it's definitely useful to set up the inventive step or perhaps some context or so on. And if you're really clever, then you're able to write the background in such a way that it makes your invention look obvious. And you'll find that out either in court or during prosecution when the examiner says that you already admitted that it was obvious. Summary, which is usually a claim summary, basically a copy of the claims, but it can also be used to summarize the invention. A list of figures and the figures themselves. Some inventions require figures and some don't. In any case, the figures are connected to the rest of the specification. You have reference number in the figures. Each figure has a number. In the text, you refer to the reference numbers and to the figures. A lot of people use the figures as an informal index to the detailed description. Now, some countries expect you to write a technical problem that is being solved. And those countries, you would have a section technical problem, even those countries often allow you to have an implicit technical problem. I consider talking about the technical problem is often a distraction, or it can be a guide to whatever it is you're doing. Few more formal parts of the application. Detailed description of the invention. It has some other names, but usually it's a longer section, and you describe embodiments and you describe them using the figures. And one of its important jobs is to give support and enablement for the claims, which we'll get to in a second. You have an example section. Legally, it may be considered to be a part of the detailed description, but the laws which apply to interpreting what you have in the examples and interpreting what you have not in the examples can be different in different countries. The example section is often very long, 50, 60, 70, 90, 100 examples, just so you know. Mechanical patents sometimes have a list of parts, the name of the part and the reference number. And then we get to the claim. I'm sure you noticed I didn't talk about appendixes, but you could have an appendix. In any case, the claims, they talk about the monopolies that you want to get, and it includes one or more trees of claims. A tree of claims is an independent claim, followed by 0 or more dependent claims. Last but not least, the file wrapper, in other words, a record of the discussion with the patent office, is also a part of the document. And in some sense, also litigation records act as formal parts of the patent document. How and why, we'll see in about half an hour. So these were formal parts. More interesting are functional parts. And when I say functional parts, I mean a part of the application that's supposed to do something. Here's a few examples, and I'll give more details later. Stories. Part of the document tells a story. Sometimes a document is supposed to help in a deception. Sometimes a function is a legal function, for example, providing enablement or giving non-medical use examples for medical devices. Sometimes the parts are predefined fallbacks. Part of it is cognitive scaffolding, meaning structures that you put into the application simply to help you draft it or perhaps read it. Sometimes you do publication in the application in order to cause problems for the competition. It's called an intentional publication. Some parts of the application have as a job to be done PR or sales or marketing, or maybe just supporting such activities. Psychological effects. You want people to be attracted to the parent, to be scared of the parent. You can have separate parts which do that. Often you describe the ideas, and the law does not require you. And before you get worried that the application is going to be too long, the same part of the application, the same paragraph, can cover multiple functions simultaneously. Let's talk about this function I call stories. So, pattern document tells multiple stories directly, and it also supports additional stories that you might have to tell later on. So support is when you or your lawyer in court tells a story, and telling a story is when somebody's reading the document and you want them to read a story. I've spoken before about how stories are an organization tool. They help you make some sort of sense out of the mess of details that you have in the application. But it's also an output of the document. You want the document to tell a story. You want people to read the document and nod their head when they get your stories. Let me give you a very simple example. Let's talk about stories that are meant for PR or for psychological effect. And the story might be written in an implied way, but with the goal of evoking the story in the mind of the reader. So let's say we have a potential partner. We might not even know who it is. And we put in the application a figure which shows the product of the partner with the add-on that you invented. When the partner reads or looks at that figure, they say, my product can be made better using this patent. Okay, that's a story. Okay, you didn't actually say it, but you strongly implied it. Stories can also be technical, and in this sense, they describe cause and effect. So let me give you an example of a lollipop. I'm sure everybody knows what a lollipop is. You hold a stick, it has in it some sugar candy, and you lick it. And songs have been written about it. Here's 3 different stories. They can all be told in the same patent document, and each one of these technical stories will be helpful in different situations and considering different prior art. So the first story is that people love eating hard candy, but it gets sticky, so you can't hold it in your hand. You have to eat only small hard candies. If you put a stick into the hard candy, then you can hold the stick by hand and have a big hard candy and lick it as much as you want. And the fact that the candy is hard is what keeps the stick from falling out or from, flopping around. That's one story. Now, a different story. And here the starting point is that having a candy on a stick allows you to keep your fingers clean. But the fact that you're using a stick allows you to use not only any candy, but in particular, it allows you to use hard candy. And here's the third story. There's a synergy between using hard candy and a stick. It gives you a new thing called the lollipop, which gives kids whole new experiences. Okay, so we have these 3 different stories, and all of them can be told in the same document, and there's probably no reason not to. A particular type of story is an argument. And if you've read, argument can use logic, can use emotion, and it can use ethical considerations. And we use all of them. Some people, I do less of that, believe in putting explicit arguments in the patent application. For example, you say, this piece of prior art has this problem and we overcome it. Often the arguments are implied. It's not a complete argument, but there's support for it. You talk about advantages you have. Well, the prior art doesn't have that advantage. Or you talk about a disadvantage of the prior art. Well, you don't have that disadvantage. Or some logical progression. You have a background, and then you have a summary, and you say, wow, there's a contrast here. Obviously, we have an invention. A particular thing about writing arguments in a pattern application is that you often intentionally leave gaps, either because you're going to have data later, which helps bridge the gaps, or because you're not sure exactly what your argument is going to need to look like during prosecution. If you're preparing your arguments for use in pattern prosecution rather than, let's say, going to court, there's two things you should know. One, that the support elements for the argument need to be in the application. And in other words, it's difficult to argue that your device is cheaper if the application doesn't talk about it at all. And the second one is you can't assume that anybody will actually read your argument and or understand it and or be convinced. So usually, even if you write an explicit argument in the application, you're going to have to repeat it, explain it, focus on it during prosecution. There's an issue of authority. People have to believe your argument. If your application has nonsense or has items which contradict each other, then whoever's reading the application won't believe what you're writing, will not be convinced by the argument. And of course, anything you write will be used against you in particular arguments because they're logical. It's easy to turn them around and use them against you. Another important type of structure is cognitive scaffolding. Now, the fact that you have structure in a pattern application, it's not just 40 pages of text continuously, is already support for your writing and sense making. And it definitely helps the drafter understand what he's doing. And it definitely helps the drafter decide where to put new information. And super important, it allows you to break down the work into modules. And each module, you know what's in it. It's much easier to do. Completely different type of cognitive scaffolding is a section, I call it the overview. Other people put it in the summary, which gives you, the drafter, both space and some amount of structure to explore and expand on the invention without being tied down to any specific embodiment or any specific implementation detail. Usually, in other parts of the application, you do need to think about these other things. More scaffolding is in figures. For example, a system figure or an ecosystem figure. They help you, it's called a checklist, go through all the items that could be affected by your invention. If you have a user journey flowchart or dedicated operation flowchart, so you can go step by step and make sure that each step you think carefully about how it relates to the invention, okay? Dividing this task of what's my invention doing here into what's my invention doing in this step, what's it doing in this step, is cognitive scaffolding, and it's really, really helpful in writing and in understanding and in make sure you're tracking what you're doing. Another type is figures which show a contrast between A and B. They help you focus on what you have to talk about. Figures can also help you identify ripples, meaning consequences and other effects of your invention, not just in the invention itself. Claims act as cognitive scaffolding because you might say, obviously, any claim language needs to be supported in the text. Look at it the other way. Anything we felt was important enough to claim, any language we used, is probably language which is important to define the invention, and therefore we have to make sure to write enough about it in the specification. The fact that you have the claims and you can extract the list of these details makes it much easier to make sure that you actually did it properly in the specification. Fallbacks and launchpads. So anybody who's been in the field more than a year has probably discovered that stuff happens during prosecution, prior art, and so on. And the product's going to change from what you voted. And competitors are going to do stuff. And the market is going to change. And your business model is going to change. And your revenue streams are going to change. So when you write the patent application, you have to prepare for all of these things. And you basically have fallbacks prepared ahead of time because you can't do them later inside the patent application. Okay, so that's bad stuff. What about good stuff? Unfortunately, you're not allowed to have a placeholder in the application. Whatever you write, that's what you have. Some places allow you to have Easter eggs. Okay, it's actually written there in the application, but people don't notice it. You can definitely write broad claims if you have support for them, but broad claims have a low probability of success. So if you really want to get broad claims, you have to have much more details and diversity than just, placeholder. We have several general issues, especially in the European Patent Office, but not only. There's one I call anti-cherry picking laws. You can't pick stuff from different places and put them together. Some countries have anti-broadening laws, which mean once you claim something, you can't broaden the claims later. Perhaps not even in a divisional. And speaking of divisional, some countries have anti-chaining laws, which means that you can't file divisional after divisional after divisional. So even though we can talk about fallbacks and launchpads, you could be rather limited in what you can use. Very important, if you have fallbacks, to prepare combinations of fallbacks ahead of time, especially in the patent office. If you take two different fallbacks and try to put them together, you can already guess it's going to be cherry picking and not allowed. Here's a few other parts that I mentioned before, ideas. So in case you don't know, patents do not protect ideas as such. They only protect the implementation, which means that you don't have any legal requirement to actually describe the idea in the application. But ideas are often described, at least implicitly, meaning if I read a patent application, I can figure out what ideas are hiding there. If you explicitly provide the ideas, then this idea can act as cognitive scaffolding for people reading it, and it can definitely help you doing prosecution, because if the examiner understands where you're trying to get, you can start on the right hand. Mechanisms of operation. How does something actually work? What is the physics behind it? What's the biology behind it? It's optional. No law requires it. It can be helpful. It can be problematic, but it exists. We mentioned before strategic publication. I know Guy likes it. So you're intentionally putting something in your application in order to damage the possibility of other people to obtain a patent. If you want to do deception, or if you want to show that you have technical authority, it's a type of PR. For example, if you put in 20 unnecessary equations, okay, I already said it's unnecessary by law, but by putting it in, you show technical authority. People say, oh, whoever wrote this patent, this invention is complicated. He knows what he's talking about, okay? That can have value. If you want to use your patent for marketing, broad claims, broad language, figures that people can showcase. Who do you want to market to? Let's just think about a few people: an investor, potential partner, an infringer. You want them to be scared. The IP attorney doing due diligence on the other side. Okay, so all of these people in all of these situations, possibly you'll have a part of the patent application that you can point at and say, that's a job. Mentioning people, one of the problems with patent applications, they're going to be read by lots of different people. Some people make fun of members of the jury by saying that people too stupid to know how to avoid jury duty. Okay, well, I don't know if that's true, but definitely the technical business and legal proficiency of a jury member is very different from a judge, and both of them are very different from your competitor, and both of them are very different from the patent attorney on the other side. So the same document has to speak with multiple different voices, different language, jargon, different level of technical complexity, legal complexity. Sometimes you have to have business type language as opposed to technical type language. It might be in different parts of the application. It definitely indicates figures. Some figures are good for technical people. Some figures are good for business people. Now, even when we talk, let's say only about patent examiners, okay? I'm writing only for patent examiners. People are different. Some understand words better. Some understand graphs. When they see a formula, they understand it quickly. Some people need to see actual results. Some of your readers are going to be reading the whole thing, spend an hour on it. Some are just going to skip through it, browsing. So you have to consider the context in which people will read. And like I said, multiple voices. You need to have parts of the application that you prepared ahead of time to deal with these things. And in some of the cases, you want to intentionally inject uncertainty into the patent. Sometimes you don't want it to be completely clear to somebody what's going on. Can't do it with the invention because then you might not get a patent, but you might be able to do it somewhere else. And I'll give a few reasons why later. Now, some parts of the application are only implied or evoked in the mind of the reader and not explicit. It means that these things are usually not claimable. So usually they're actually a freebie for whoever else it is. But you still can't avoid it. And sometimes it's just not done. I'll give you an example. When we write an application, some of the embodiments are more plausible and some of them are less plausible. Okay? So there's a range of plausibility in your application, starting from ha 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 to wow, I believe this is going to work. Where can I invest? You're never going to say, here's my range. You're never going to say this embodiment is less plausible, but anybody reading it who's in the know will be able to identify that you do or don't have this range of plausibility. Another example is these PR effects and psychological effects. You're not going to say, be afraid, be very afraid. You're going to have language which implies that maybe one day you're going to get a broad patent and they should be afraid, very afraid. Sometimes you couch what you're writing in such a way that somebody reading your patent will not understand the value of what you have. Why would you do that? Because you don't want to be opposed. You want to get the patent. And when the time comes up and they see the context, suddenly they understand why you wrote it in your patent application and your claim. The goal of the patent application, that's not written, but it exists. You try to hide it. Often you fail. Things that you don't know, they're not clear yet. Sometimes you don't write them because you just don't know, and sometimes you intentionally don't write them because you don't know. And I'll say again, you can't always hide things successfully, and especially you can't hide trade secrets successfully. And when you write a patent application, and often at least hints at trade secrets, even though you didn't mean to do it. And one of the most valuable trade secrets out there is that you're infringing somebody else's patent. The reasons for why you put something inside, you keep hidden, if you can. The futures that you're envisioning or that you're scared of or that you hope that can happen are hidden. Okay, so these were formal structure and functional structure. And as we know, it's a long, complicated document, so it also has a physical structure. First, we'll talk about the overall physical structure, but not of the whole application, just of the detailed description. Why? Because that has a very nice structure. Usually what you have in the detailed description is a series of one type or another of embodiments or examples. And you also have some general section which is common to multiple embodiments. And of course, that's a problem to do that in some countries, but that's what's done. Let's say definitions. As used herein, DNA means such and such. Okay, that's a definition. It's common to all of your embodiments. The shape is geometric. Okay, usually it's, let's call it tree shape. And I have a picture in case you don't know what a tree looks like. So that fat thing on top is this common stuff like definitions and so on. And then we have a general embodiment and we have three alternatives, how to implement it. And some of these alternatives have additional details or additional alternatives. A real patent application usually has more than one tree. And these trees are often linked together, either at the root, because they use the same definitions, or somewhere in the middle, because you have a node. One of these boxes is called the node, which is shared between two trees. And one of the interesting situations is where you start in one place and you go to another. So I start writing about one invention, which is knives. And then one of my embodiments is using a knife to cut up a watermelon. And now I have another tree forming on what a cut up watermelon looks like. Okay, it's another invention. So the trees, one of them spawns the other one, but in reality, cut up watermelons, you don't have to cut up using a knife. You can take a saber-toothed tiger and use their teeth to cut up the watermelon. And that's especially common when you talk about a device and ripples which are formed. And these ripples can be made with a different device. So a few common shapes of patent applications are bamboo, that's a long stick with bumps in the middle, a palm tree, which is a long straight section, and on top you have floppy leaves, a fern, which is leaves going in all direction from a base, a full branching, if you've ever seen a tree, so you have a branch and then another branch and then another branch and splits again and again and again. And some patent applications are more like an hourglass. You have a lot of details, then you have a choke point, then you have, again, a series of options. If you think about it, you've definitely seen patent applications built like this. I'm not going to go into detail what each one means, but in order to give you a feeling for the format, if you have a node with splits, it means that you have alternative embodiments for that. And if you look at the tree here, not all subtrees have the same complexity, and one of the nodes can be bigger because you have more detail. And basically what this is telling you is where was the emphasis put on in the drafting of the application. There's a lot of information in there. If you put very little emphasis on something, then it's probably less important because you're probably not going to get good protection there. Shape. Beyond shape, the application has mini-structure, microstructure, nanostructure, and atoms. So mini-structures, if we look at a single embodiment, a single embodiment usually has one or more figures supporting it. And it often starts off or some other way highlights what are the critical features in this embodiment. And of course, sometimes what you choose to be critical is not really what's critical for your own reasons, whatever they may be. But you also have less critical features. So in the writing, there's always going to be language which distinguishes what is critical from what is not critical, what is optional and what has alternatives. Okay, this defines the physical structure of a description of an embodiment. Another thing you usually have in an embodiment are details, especially numerical details. It's between 1 and 25 millimeters long. And if you're lucky, you also gave some justification why different values have more value in certain situations. Talked about alternatives. Even if you're describing an apparatus embodiment, you're often going to explain how it's used, all inside one embodiment. If you don't, you're going to have a link with a different embodiment. Okay, so you have one embodiment saying, this is my magical black box. And then you have another embodiment saying, here's my hidden software inside the black box, but you need to link between the embodiment figure 1 of the black box and the embodiment figure 2 of the flowchart, what's happening inside the black box. Some of these links are implicit, which is often a problem, and some of them are explicit. Black box can be, of figure 1 can be used with any of flowcharts 2, 3, 4, 5. Sometimes the link is contrast. Black box of figure 5 is similar to black box of figure 1, except that it's not black, it's actually painted blue on the inside. So you have contrast. And another structural feature is repetition. Without getting into the question whether you should or shouldn't repeat sections again and again, sometimes you have unintended changes in one of the repetitions and you didn't do them in the other one. And you meant to, or you should have. What's hiding behind all of this is that when you have an embodiment, you usually have a reason why you're presenting the embodiment. And the question we have to ask, as part of the mini structure, did you also explain why this embodiment is being shown, or did you decide not to? Either case, again, it's part of the structure. Microstructure. Let's talk just about a single paragraph. So a paragraph is used to expand a single idea, at least in classical writing. It often has a topic sentence. It can have a format which encourages in the person drafting it either open thinking or closed thinking. Open thinking means that it makes you think more about the invention. That takes time. Or closed thinking means I don't have to think anymore, I already wrote it. And inside the paragraph, usually, or often, you have optional features and you have alternatives. And there's some sort of relationship which explains inside the paragraph which options and which alternatives go together and why. Another structure you have inside a paragraph is a connection to the previous paragraph or the next one or the one 4 down. Okay, so paragraph doesn't stand alone, it's in a context, and you can control the context by providing this structure. Paragraph is made out of sentences. These sentences have a relationship between them, and they also have a relationship with the results, benefits, advantages you talk about. And again, it's part of the structure. Let me give you a few examples of special kinds of paragraphs, not as, regular embodiments. Definitions. Like I said before, as used herein, DNA means such and such. So it could be tied to a clear context. It could have both numerical parts and qualitative parts. Your DNA, does it use only 4 types of, what are they called, base pairs? I don't know. Did you write the number 4? Sometimes you don't have an explicit definition, you have an implied definition. An implied definition might be unable to escape the local context. In order to escape the local context, you have to often explicitly tie that local definition to other places. It's the same thing with a figure. Figure 2, the flowchart, is it explicitly linked to figure 1? Sometimes in the listing of the figures, you say figure 1 is a black box, figure 2 is a flowchart of a method that can be used inside the black box. And my favorite is a single sentence paragraph. Single sentence paragraph is usually very constrained on its own and also constrains the person drafting it. It usually encourages closed thinking because you wrote it and you can't write anymore. but it's a special case of microstructure. And now nanostructure. Basically, a single sentence. Single sentences, they have phrases, and these phrases are related to each other. Connector A connects element B together with element C. Well, how many items do you have in the relationship? I just described A, B, and C. You could have just two, you could have more. How strong is the relationship? Is the relationship bidirectional? How many relationships do you have in a single sentence? If that sentence is part of a paragraph, we ask, will that paragraph elaborate on these relationships and on these, let's call them noun phrases, they don't have to be, later on? And why is that important? Because sentences are very good at hiding magic. Magic means that two things work together, but you never said how. And also very good at hiding made-up phrases. Okay? And optimal connector configuration. Okay, do you know what that means? I don't know, but I wrote that item B can be connected with item C using an optimal connector configuration. But if I don't explain what that means, the sentence is useless. If you have a phrase which was important enough to write in a sentence, then maybe it should have a reference number in a figure. That's another part of the sentence, reference numbers. If you do have a relationship, how specific are you in what exactly is related to what? Not generally, but which part of element B is related to which part of element C? Sentences can be complicated. And if they're complicated, the translator might mistranslate them, and an examiner might misunderstand them. Every sentence has some level of ambiguity and some level of passivity, and you have to decide how much you want to have. Every possibility causes problems. We got the smallest element, individual words. So individual words, obviously, are supercritical. Words define, but each word also brings its own baggage, which it imposes on the application. And if you choose the words correctly, you can get exactly the specificity, breadth, correctness, or whatever you want. If you don't match up between the words you have in the claim and the words you have in the spec, you will have problems. And if you do match up, guess what? It's a relationship between two different structures in your document. If you make a definition of a word, okay, is that definition coherent with other definitions? Is the use of the word coherent, uniform, whatever you want to call it, all through the application? Okay, so these words define a logical structure in your application. Usually when you have terminology, you can see it in the claims. It's often some type of hierarchy. I have an animal. The animal can be a mammal. The mammal can be a house animal. The house animal could be a cat. The cat could be gray. It could be my gray cat. Okay, so this is the hierarchy of definitions of what I mean when I say cat. And you could define it explicitly, you could define it implicitly. Unfortunately, it often includes overlap or even contradiction. For example, the device comprises a black box, and the black box comprises a device or is a device. And you have to be super careful for any words you use in the claims. I believe that if you're too careful and you have too much uniformity, only one word is ever used to mean one thing, then you have a risk of a single point of failure. How many of us have been told by a client, A must be such and such, or A works by doing such and such, or B is a such and such. And then we discover 2 years down that the client was wrong, but it's too late. It was a single point of failure, and there's nothing left. Sometimes we use the same word or similar words for two different things. For example, store. Is it physical storage or electronic storage? Are we talking about the verb or about a noun? Sometimes when any of these issues are brought up, patent attorneys say, oh, patent attorney is allowed to be their own lexicographer, which I say, yes. You can also pick your nose in public, you know? But don't do it. Words are all historical. They all have baggage. They all have meaning. They all have context. Usually, whatever that is not aligned with the invention. So you have to ask yourself, what are you going to do in order to separate all of this baggage from the words that you're using? Last but not least, the bad words, you know, like must, require, only, each. Some of them might be only problematic, but some words are bad, like I said. I've talked multiple times about the word relationship, and the reason why I keep on and give it its own slide is simply because there's no reason to think that relationships between items are more important than the items themselves. Just that when we write, we have a lot more words about the item. So I'm reminding again, when we talk about structure, part of the structure is that we have a sentence here and a second sentence here, and part of the structure is that we have a connection between the two sentences. Our good friend, the file wrapper. After you file the patent application, the application keeps having things added to it. In fact, even after grant. When you talk to the patent office, you explain stuff. So this is a file wrapper, and the minute the file wrapper explains something in the application, you've changed your document. When you amend the claim, you're doing the same thing. You're affecting what the document's saying. When you use a patent to sue somebody, you're making an interpretation. Often the court will hold it against you. When you file a continuation application, again, you're now making your document twice as long. What's common to all of these things is that the person who owns the patent often has possibility of deciding how this patent document will evolve. And all I'm saying is do it intentionally. So do we have total mess of a patent application, all of these parts, all of these structures, all of these pieces? Well, the answer is it's a job of the patent attorney to fight anarchy, using structure and integrating and having a narrative and doing coherence and so on. But I'm reminding you that I believe an application should have some flexibility. And one of the ways of having flexibility is having some tension, some lack of coherence, some alternative. EPO does not like it. I'm not going to say I like it, but if you don't do it, I said single point of failure. I talked about stories. Also, stories have this problem. If you have multiple stories, they might start contradicting each other. But having coherent stories, I mentioned the EPO, having coherent stories is very helpful dealing with the European Patent Office, for example. Okay, so we have a patent, and now we're trying to figure out if we have good structure or not. Enter AI. I'm not going to go into detail here, but basically, AI is great at analyzing text, and therefore, I made a list of stuff that it would be very nice if somebody checked in patent documents, and I believe that AI can do it and do a pretty good job. To be proved. This expression in Latin means that the paper does not blush. In other words, it doesn't refuse ink, but it's not true for patent applications. You can't do everything you want in a patent application. You can't have all the embodiments you want. You have to do groupings. In the seminar, I mentioned a case where 2 trillion molecules, it's not supported in the application to choose only a particular set of 61 of them. Okay, that's a recent decision. If you have a lot of stories, well, the application's not going to be clear. So what it means is that you have a lot of triage going on. And one of the problems is, of course, that the patent attorneys are quite limited in what they can handle. And readers as well. I'm not going to go through all of these common mistakes, but the most common mistake has to do with linking between parts. I either overlink things together or I don't link them enough at all. And that's really what you should be careful about. If you do everything I said, you can use a structure to help you review documents, to help you draft complicated documents, to help you read a patent that somebody else wrote. All patent attorneys put structure in, or most of them. It helps you skim the patent because you know what you're looking for. And during due diligence, if you have bad structure, people think you're an idiot. And if you have good structure, the person evaluating can understand what you thought was important. And I don't know if you want them to understand or not, but they can. Conclusion, there's lots of structure everywhere. The structure is for everybody, and the structure is important. And just stuffing stuff together is a structure literally, but from a practical perspective, it is not a structure at all. Okay, I'm going to stop my recording. And if anybody has any questions, comments, insights, please do.